Okay, this video is going to take you through the study guide for Chapter 7 to prep for our test that we're going to have. So, here we go. For number 1, it just says find the square roots. So, we have negative square root of 81. Well, I know the square root of 81 is 9, so with that negative in front, that would make it a negative 9. Okay, number 2, plus or minus the square root of 1/9. Now remember, whenever we have a fraction, we're actually taking the square root of the top and the square root of the bottom. So we're going to have plus or minus because that was the symbol in front. Square root of 1 is 1, and the square root of 9 is 3. So plus or minus 1/3. Okay, for 3 and 4, we're finding the cube root. So the cube root of -1, so your cube rooting is figuring out what number times itself again would give you the number in here. So the cube root of -1 would be -1. The cube root of -8/27. So again, just like we did on number 2, we're actually taking the cube root of -8 and the cube root of 27. Okay, now it's going to be negative since there was a negative in there. The cube root of 8 is 2, and the cube root of 27 is 3, so -2/3. Okay, for 5, starting at number 5, we're going to evaluate the expression or solve this. Okay, now remember, you always want to do the square root part first. So, looking at number 5, we have 10 minus 2 times the square root of 9. Well, I know the square root of 9 is 3, so this would become 10 minus 2 times 3. Order of operations says you have to multiply first, so 2 times 3 is 6, and 10 minus 6 is 4. Number 6, we have the square root of 0.25 plus 2.4. Well, that square root ends up being 0.5, or 5/10, and then we're going to add 2.4, so our answer becomes 2.9. All right, now look at number 7. 70 minus, and then we have the cube root of 64 cubed. Okay, we've been talking about opposites a little bit, mainly when we were solving equations, adding and subtracting our opposites, multiplying and dividing our opposites. The cube root and cubing something are opposites. So basically what happens here is your cube root and your cube cancel each other out. So you're just left with 64. So for number 7, this becomes 70 minus 64, which is 6. Okay, number 8, we have 5 times the cube root of -27, so we'll do that part first, and then plus 18. So 5 times the cube root of -27 would be -3, because -3 times -3 times -3 would be -27. And then we're going to add 18. You multiply before you add, so 5 times -3 is -15. And then when you add 18, you get 3. Okay, number 9 says the area of a square game court is 64 square feet. How long is one side of the court? So here's a court, it's a square. I know the area is 64. Now, you know on a square, all 4 sides are the same length. So in order to get the side, we would have to take the square root of 64, which is 8. So the length of one side would be 8 feet. Okay, looking at number 10. says the ratio of the areas of two squares, which are pictured right here, is 25 to 9. The side length of the smaller square is 30. How long is the side length of the larger square? So in the smaller square, we have 30 by 30. And we want to know what the side length is of the big square. But what they told us is the ratio of the two squares is 25 to 9. So the best way to solve this is to set up a proportion. So the first thing I'm going to use is my ratio that they gave me, 25 to 9, 25 over 9. That's going to be equal to, now remember, we did the big square as the numerator, smaller square as the denominator. And we're talking about the areas of the two. So to find the area of the bigger square, it's length times width. X times x is x squared. The smaller square, 30 times 30, is 900. Okay? And then to solve a proportion, you just cross multiply. So 9 times x squared is just 9x squared. And then 25 times 900, let me pull up my calculator here. You get 22,500. Okay, and then we're just going to solve this for x. So I'm going to divide by 9 on each side. So x squared is going to equal 2,500. And then I have to take the square root of that. So x is going to equal 50. So that means that each side of that larger square is 50, and then our measurement was in meters. So 50 meters. Okay, moving on. 11 and 12, find the missing length of the triangle. So remember, we have right triangles here. So we have to use the Pythagorean theorem. So I'm going to write the formula right over here. You use this for any right triangle. And remember, C is always your hypotenuse, the side that is opposite from the right angle. Okay, so on number 11, to set this up, we have 10 squared plus y squared equals 26 squared. And then we just solve. 10 squared is 100. 26 squared is 676. And then my goal is to get y by itself. So I'm going to subtract 100 on each side. So y squared equals 576. And then remember, we still need to take the square root of that. Okay, so the square root of 576 is 24. So y in this case will equal 24. Okay, exact same process on 12. Plug in my numbers. This time I'm trying to find c. So we have 10 squared plus 7.5 squared equals c squared. Well, 10 squared is 100. 7.5 squared looks like is 56.25. Add those two together and you get 156.25. But that's c squared, so remember, to get that c all by itself, we need to take the square root of this. And you get 12.5. Oops. Didn't mean to delete all of that. But we got 12.5 as our answer, and then our labeling would be in meters. Okay, 13 is going to be the exact same process. Okay, it says a slide is 21 feet high. So there's the 21 feet. What is the length of the slide, which is the hypotenuse? Okay, and then they've given us the distance down here as well. So we're trying to find C. So as I plug this in, we have 21 squared plus 28 squared equals C squared. I'm going to pull up my calculator here. 21 squared is 441. Okay, 28 squared is 784. Alright, so when we add those two together, you get 1,225, but that is equal to C squared. So don't forget, we need to take the square root of that, and it looks like you get 35 feet as your answer for how long the slide is. Okay, now we're going to flip over to the other side. Okay, for 14, 15, and 16, they just want us to classify the real number. Okay, so keep in mind, we are answering whether these are going to be rational, and that is if it can be written as a fraction. And irrational is the opposite. Okay, you'll have, we mentioned that pi is irrational. We also said that it is not a repeating or terminating, meaning it stops, decimal. Okay, so 14, negative square root of 16. Well, the square root of 16 is 4. So negative 4, that would be rational. Okay, 15 says 3 pi over 2. Now I know it looks like a fraction, so you may automatically think rational, but the fact that it has a pi in it, pi is irrational. So that would make this irrational. And then 16, 9.63, that's repeating. The fact that it's repeating would make it a rational number. All right, 17, 18, and 19. They want us to estimate the square root. So, if I take my, and they want us to round to the nearest integer, so whole number, and tenth. So if I pull up my calculator, and let's do 37 first. Square root of 37. Okay? So if you round this to the nearest whole number, that is going to round to 6. If you round it to the nearest tenth, that's one number past the decimal, you get 6.1, because that 8 would tell the 0 to round up. Okay, number 18. We have the square root of 52. And keep in mind this is going to be negative. Okay, so as a whole number, this would be negative 7. As tenth, it would be negative 7.2. Okay, and then 19, the square root of 3.3, put that in my calculator, and it looks like 1.8 is going to round it up to 2, and then when you keep it with the tenth, 1.8 is what it would round to.